Welcome back everybody to Desktop Inventions. Now in the last video we went over how to make a self-filling food bowl for pets. If you haven't seen that video, I'll put a link in the description down below. Now during this project there are some major challenges along the way. And for the most part, to keep the video short and interesting, I cut out those challenges. But today I want to go over the top 5 lessons learned from this project. Alright, number 1 here, so part support structure. So here you can see an example of this sliding piece that I 3D printed. In order to save some time, I 3D printed it to minimize the support structure. But the support structure I did have was inside of this cylinder piece. Now this took probably 30 minutes or more for me to dig and cut and punch out all of that material. In fact, if this cylinder were any smaller, I don't think I would have been able to get the material out at all. Alright, so let's take a look at this slider piece here in Kira, the slicing software. So this is how I initially chose to 3D print this part. You can see underneath the red areas are the areas that need support. And I did it this way to minimize the amount of support material needed. So you can slice it here. You see this takes about 7 hours and 15 minutes. When we go to the preview, that's where you get this whole cylinder that's filled with that support material. And that was really the struggle to break that out of there. So let's look at a different way we could have printed this part and see how that changes the time to print it. So if we print the part upright like this, we're going to have a lot more support material because this whole underside of this surface needs to be supported. You'll see that takes a little bit longer to print, 9 hours, but once this is all done, you can see there's a lot of support material here. Once this is all done, I found that this was actually a lot easier to remove the support material. Yeah, so the big takeaway here is not to just minimize the print time needed, but also think about what type of challenge or struggle it's going to be to remove the support material, or can you even remove it? Lesson learned number 2, bed adhesion. So here you can see a finished print of a linkage part. And on this part in the front end of it, it was not sticking to the bed properly. It was peeling up away as the print was going on. So after that was printed off, it would not work properly for me. You can see the curvature at the bottom of the part here. So there's a few things you can do to fix this. The first is check your nozzle height. Make sure your nozzle is close to the bed, like the bottom picture here, and not like the top. The second thing you can do is adjust your bed temperature. For PLA, you can increase it to 60 or 70 degrees, which will help adhesion. Another thing you can do is add a brim to your part. This is a setting within your slicing software. You can see here it's added several passes in the first layer around the part. And compared to the old part, it's holding the front end down perfectly flat. So that solved the issue. Lesson learned number 3, test early, test often. So with any complicated system, what you want to do when you're designing it is break it down into subsystems and test those individually. So the first thing I did here was I tested the structure of the part with no electronics, no servo motor. So pouring some food in the basic structure here and just trying to see, does the basic concept work. So knowing that the basic structure is working, the next challenge was how to motorize this structure, what to use to move it. So I wasn't sure if the servo I had was strong enough to move this. So I took a quick and dirty approach and just modeled up some little test linkages. And I actually held the servo by hand to do some initial testing. I had some mixed results on this. It wasn't perfect and the linkage wasn't working properly. But I did get enough testing done to give me confidence in this motor and this linkage was going to work out. So with confidence that I was going down the right path, I modeled up the actual motor mounting plate and linkages of the correct geometry and had some more quick test parts printed out. And with this, I was able to finally verify the full function of the device. So the basic takeaway here is, instead of spending a whole bunch of time up front on something that might not work, you can sometimes throw together quick and dirty test models so that you can get an idea early on if you're going down the right path or you need to make a change of plans. Lesson learned number 4, don't be afraid to modify your parts. Yeah, that part you just spent 8 hours printing, you want to test a new part without this extra flange? Cut it off! Who cares? The worst thing that can happen is you ruin your part. The best thing that can happen, you modify the part in 30 minutes, get your testing, and you save 8 hours of printing a new part. Oh, you forgot to put a mounting hole in your part? Get your soldering iron, melt a hole in there. Not going to spend another 8 hours to print a new part just to add a hole. Mounting holes? Who needs them? With the latest technology in cutting corners, you can just take your soldering iron and melt your parts together directly. For prototypes, why not? Quick and dirty. Lesson being, don't be afraid to modify your parts. You built them, so you can destroy them. Worst comes to worst, you can make a new one too. And the last lesson, mistakes will happen. Uh-oh, I think we have a problem. We have a short. So if that's happening, our switch is just not going to work. So let's put this together, see if it works. Oh, I made a mistake. So when things go wrong, and they will, don't get discouraged. Take a break if you need to. It's like riding a bike. You're going to fall down a few times when you're learning, but if you don't get back up and get on that bike, you're never going to learn. In fact, the most satisfying projects are the ones that had the most challenges along the way. Good, we're no longer shorted. So with that, those are my 5 lessons learned. I hope this can be helpful to anyone else making projects on their own. So if you like this video, be sure to like and subscribe down below. We'll see you in the next video.